All right, day 2 for 12.1, sequence and series. Now, yesterday you guys had this slide and we talked about what was a sequence. And we said a sequence was a ordered collection of numbers. Okay, and we said it was ordered, and that was what we were looking at yesterday, is how to figure out what those patterns were. Sequence 1, we talked about how the domain was the term, what term you were on. So we were in term 1, and the range was, what was the output? What did you get? So in term 1, our range was 4. In term 2, our range was 8. Term 3, we got a 12. And term 4, we got a 16. Now, we said this was a finite sequence. Why? Because it stopped. It had a last term. Sequence 2, when we looked at it, we had a ... a continuation. And we said this continuation over here meant that it kept going. So it continues and never stops. And we called that infinite. So we had finite sequences and infinite sequences. Now, we're going to take these sequences, and today we're going to talk about a series. A series is very similar to a sequence, except a series is a sequence that is added. So we're going to take a sequence, very similar to what we just had, 4, 8, 12, 16. And if there's commas, if you have the actual term 1 is 4. Term 2 is 8, term 3 is 12, term 4 is 16. If you have the actual terms with commas, it's a sequence. You know if it's a series when they are added. So you're taking that series and adding what you have in your sequence. 4 plus 8 plus 12 plus 16. So series is when you add them. And if you were to type all those in, you would get 40. So sequence is just the list. Series is when you add that list. Now, something that we're going to have, which is new to probably most of you, that's going to help us with these series is called summation. Summation notation. An example is listed below down here. Okay, and it says AKA, also known as a sigma notation. So summation and sigma are very similar. And that's this capital E kind of thing right here. Okay, it's a Greek letter sigma. Now, what this means, a couple things. First thing, it is used to write our series. And what do we say about series? It's when we take a sequence and we add everything together. Okay, so that's the first thing you need to recognize. A sigma is used for a series. So anytime you see a sigma, you have to know you're adding. That's what this sigma means. You're taking and adding, taking the terms and adding them. The next thing, that I is our index. And yesterday, most of the time, we had an N for our index. Okay, it doesn't matter. It can be an N, it can be an I, it can be an X. But you need to recognize that letter is your index, just like we had an N here yesterday. Okay, but this one's going to have an I for us on this example. That is our index. Now, we're going to have a lower limit, which for this example is 1, and an upper limit, which this example is a 4. And this is telling us where we're starting and where we're stopping. So take a guess. Is the lower limit where we start or where we stop? We have a 1 down here. So this lower limit is telling us where to start, which means this upper limit of 4 is telling us what? That's going to tell us where to stop. So that's like our restrictions. Where are we starting? Where are we stopping? Okay, so this is telling us what is I. I equals 1. That's where you start. So I equals 1, then what's the next thing you're going to have? I equals 2, I equals 3, and then your upper limit, I equals 4. And that's going to be the last term that you're going to have. So we're going to have 4 terms here. So what does that mean? Here's our equation, 2i. So we need to start at 1 and go to 4. And remember, the sigma means add. So we're going to take all these terms and add them together. So we're starting at 1. So our equation, 2i. So 2 times 1. That's 2. Then what do? 2 times 2 is 4. And what did we say? We're adding everything. So plus 4. Then we keep going. 2 times 3 is 6. And then where do we say we're stopping? We're stopping at 4. So term 4 is 2 times 4, which is 8. Okay, so that is our definition for our summation or sigma notation. You're going to have a lower limit where you start, upper limit where you stop. Sigma, remember that Greek E is adding, tells you what you're adding everything together. And then over here on the right is always going to be your equation. Okay, so another example. Here's another sigma or a summation. Now, what do you notice about this one? We have ends again, okay? And what is this? Our lower limit is 1, so we'd be starting at 1. But what's our upper limit? Infinity. What does that mean? Infinite. Infinity, infinite. It's going to keep going and going and going. So that's our dot, dot, dot. That's our continuation. So that's telling us we're going to have that dot, dot, dot at the very end. Okay, so let's just start writing this out just to make sure we got a hang of it. So we need to start at 1. That's what our lower limit tells us. So if we start at term 1, what are we going to get? 1, n is 1, over, what's 1 plus 1? 2. So 1/2. So what's term 2? 2 over 2 plus 1, 2/3. So what's 3? 3 over 3 plus 1, 3/4, then 4, 4 over 4 plus 1, 4/5. Now, I chose 4 terms just as an example. The key here, our upper limit is infinity, so what do you see at the end? Plus dot, dot, dot. Continues on and on and on and on and never stops. Okay, so summation, you're adding everything together. Lower limit was 1, so that's where we started, was at 1. And then technically we never stop on this one. We're going all the way to infinity. Now the next one, write the series with summation notation. Very similar to what we did yesterday, except now I actually want to write it out. Okay? So this first one, what's the pattern? 1 to 5 to 9 to 13 to 17. 1 to 5 is plus 4. 5 to 9 is plus 4. 9 to 13 is plus 4. 13 to 17 plus 4. How do I know, or what's a good key that I know I'm doing summation? It's plus signs. There's not commas. There's plus signs. So that tells me, that's one good key that I'm doing that sigma. Okay, so here's my sigma, and I need my equation on the right. I need a lower limit and an upper limit. Okay, so what do I have? Well, my lower limit's 1. I'm starting at term 1. And I don't have a dot, 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 so I stop. Well, what term do I stop on? This is term 1, term 2, term 3, term 4, term 5. So I stop at term 5. Okay, well, that's my summation. That's my sigma. Now what's my equation? Remember from yesterday, we're going up by 4 each time, so that's like my slope, 4n. But if I were to plug a 1 into that, it would be 4 times 1. I need to start at 1 though. So what do I have to do with this to get me to 1? I need to take 4 and subtract 3. So 4n minus 3 would be my equation. So there's your equation with your summation. Okay, let's look at the next one. What's happening on the next one? Negative 3 to 3 to 9 to 15 to 21. What's happening in here? Well, 3 to 9 is 6, 9 to 15, 6, 15 to 21, 6. What's negative 3 to positive 3? There's a 0 in there, remember? Negative 3 to 0 is 3. 0 to 3 is 3 more, so that is also 6. Okay, so how are we going to write this out? There's plus signs, so I know I need my sigma. I'm starting at 1. There's a dot, dot, dot. So what goes up here for my upper limit? If there's a dot, 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 it never stops. So my upper limit is infinity. Now, we said our jumps were all 6s, so 6n. And then if I put a 1 in that, 6 times 1 is 6. But I need my first term to be negative 3. So what do I have to do with 6 to turn it into a negative 3? I need to subtract how much? How do I turn 6 to negative 3? I need to subtract 9. So that's your summation for the second one. Okay, how about our next one? 1/3, 1/9, 1/27, 1/81. First thing you should recognize is there's a 1 on the top. Okay, so here's my summation. I know I have a fraction. There has to be a 1 on the top. Okay, now, second thing, let's go ahead and write in our limits, upper and lower. So lower, I have term 1, term 2, term 3, term 4. And do we have a dot, dot, dot? No. So we stop at term 4. So lower limit of 1, upper limit of 4. Now, we said we already know that there's a 1 on the top. So let's look at our bottom. 3 to 9 is plus 6. 9 to 27, what is that? Plus 18. 27 to 81, I don't even care that I don't know what it is right now, but it's not 18. Okay, so what do we notice here? The jump is getting bigger and bigger and bigger. Wonderful. Hold on a second. So if the jump is getting bigger and bigger and bigger, we need to notice it's something with powers. Okay, well, our squareds, 1 squared, 2 squared, 3 squared, 4 squared, 5 squared, it's not our squareds. Does it have to deal with our cubes? 1 cubed, 2 cubed, what's 3 cubed? 27, 4 cubed, 64, nope, it's not our cubes. Other things to look at are powers in a sense of n as a power. 2 to the first, 2 squared is 4, 2 cubed is 8. So going kind of the other direction, 2 to the fourth is 16. Well, how about 3? What's 3 to the first? 3. What's 3 squared? 9. What's 3 cubed? 27. What's 3 to the fourth? 81. So this is powers, but this is powers on a 3. So this is 3 to the n. So 1 over 3 to the n with a lower limit of 1 and an upper limit of 4. Now, find the sum. So this one's easier. All we got to do is write them in and add them. Okay, so where are we starting? Lower limit is 1. So I need to start by plugging in 1, and then 2, and then 3, and then 4, and where do we stop? Our upper limit is 5. And then since it's a summation, we're adding everything. So 7 times 1 plus 7 times 2 plus 7 times 3 plus 7 times 4 plus our upper limit, 7 times 5. So we started at 1, our lower limit, went up to 5, our upper limit, and when you type that in your calculator, you get 105. Now, the next one's not hard, it is just takes a little bit of time. Now, first thing I want you to recognize is our lower limit is not 1. Our lower limit is 0. So make sure you always look at your lower limit. It does not have to be 1. So first thing we do is we'd plug in a 0. So 3 times 0 squared minus 1. Then we'd plug in a 1. 3 times 1 squared minus 1. And then where would we stop? We'd stop at 5. What do we do in between each of those? We have to make sure and add everything in between. Now, this one would take a little bit of time to type in your calculator, or you can do it by hand. Okay, but either way, just make sure and take your time. It's not that hard. You just got to take your time to make sure you don't make little mistakes. So type it in, do it by hand. I'm doing it by hand. 0 squared is 0, 1 squared is 1, 2 squared is 4, 3 squared 9, 4 squared 16, 5 squared 25. Then I multiply 3 times 0, 3 times 1, 3 times 4, 3 times 9, 3 times 16, 3 times 25. Lastly, subtract and add them all together, and you get a 159. Okay, next one. Find the sum of the series. Starting at 1, that's my lower limit, going to 25, that's my upper limit. First thing you should recognize is this is supposed to be my equation, but what do you recognize? Is there a variable over here? No, there's no I, there's no n, there's no x. So is there any place for me to actually plug my lower limit? No, there's nowhere for me to plug it in. So I am just adding 1 plus 1 plus 1 plus 1. How many times? from 1 all the way up to 25. So my term 1 is just 1. My term 2 is just 1. My term 3 is just 1. Term 4 is just 1. And how many terms am I doing this for? I'm doing this from 1 to 25, so I'm doing this 25 times. So what's your answer? If you add 1 25 times, your answer is 25. Now the next one, lower limit of 1, upper limit of 30. My equation is just n. So when I plug it in, I start with 1. I get 1 plus, then what's my next term? 2 plus 3 plus 4 plus 5, dot, 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 all the way up to 30. Since this is just n, we're just plugging it straight in. So we're just adding 1 all the way up to 30. We get an answer of 465. Now, these will bring me to a couple of our special series or special patterns. The first one is that one of the one where there was no variable next to it. Okay, and we did that one. We said we started at 1 and we went all the way to 25. What did we say our answer was? 25. So when this is just a 1, you're adding 1 however many times you're going. So your answer is always going to be whatever that n is. I'm adding 1 25 times, so my answer was 25. Okay, so that's your first special pattern. Your second special pattern is the one we just did a second ago as well, where we had just the n. Okay, so here's the rule. If we start at 1, we go to n, and our formula is just an I, or just an n, just an x, whatever we have as a variable. But it's just that variable. Okay, we did this for 1 to 30. And we said it was 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 all the way to 30, which that wouldn't take forever to type in our calculator, but it takes some time. Okay, this is the special pattern. If you have just an n, you can use this special pattern right here to make it a little bit easier. So whatever this n is, plug it in the pattern, you'll get the same answer. So for this question, n was 30. So we'd have 30 times 30 plus 1 divided by 2. Well, what is 30 plus 1? 30 plus 1 is 31. So you have 30 times 31 divided by 2 is 465, which is the same answer we got just a second ago. Now, the last special pattern we're going to talk about is right here. And you can use this anytime you have an I squared or n squared or x squared. Okay, and we're going to look at this one on the next slide. But whatever your n is, you plug it in, and it's going to make it a lot faster for you to get to your answer. So here's our 3 special patterns. 2 more examples. This one right here. What is this special pattern? Is it just the 1? Nope, this is the I. But what's the difference? This is a 4 in front of it. That doesn't matter. Take the pattern for the I. And what do you think? Take the pattern for the I. How do I incorporate this 4? And then multiply it by 4. It's the exact same concept, and it's going to make it a lot faster instead of writing this out 25 times. Okay, so n is 25, so that's what I'm plugging in for my number to make this one a little bit faster for us. So we have 4 times the pattern. 25 times 25 plus 1 divided by 2. 25 plus 1 is 26. Type it in your calculator. 25 times 26, divide by 2, multiply by 4, and your answer is 1,300. Now, the next one, hopefully you recognize. Pretty easy. I got an n squared, so I'm up here. And I don't have anything extra outside of that n squared, so I'm literally just plugging it in. I don't have anything like this extra 4 to do. So, what's my upper? 15. So I'm taking my 15 and plugging it into my n's. So 15 times 15 plus 1 times 2 times 15 plus 1 divided by 6. Okay, let's solve it. 15 times 1 is 16. 2 times 15 is 30. 30 plus 1 is 31. Then type it in. 15 times 16 times 31 divided by 6. You get an answer of 1,240. And that's going to take you a lot less time than if you were to actually type everything in by hand. 1 squared plus 2 squared plus 3 squared plus 3, or I'm sorry, 4 squared, dot, 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 all the way up to 15 squared. Okay, this is going to take you a lot less time to use that special pattern. But if you don't remember that special pattern or you don't have that special pattern with you, you can type it all in. It'll just take extra time. So here's your homework for today. This is the end of our basics for sequence and series. Tomorrow/Monday, we're going to start actually talking about specific rules.